Good day to Dr. Nadia and Dr. Azrul. On behalf of my team, I will demonstrate the current progress of our factory simulation, focusing on the workflow from warehouse to the assembly line. First of all, my name is Sumisa Kunkel and my member's name is Muhammad Kiruddin bin Barvis Khan, Luvanesh anak lelaki Krishnan, and Tibagar anak lelaki Subramaniam. So today I will present the simulation model. As you can see, there are two main sources. Sources 1 generate the part and sources 2 generate the container. This item meet at the assembly station. Here the logic combined four distinct parts into one container. This simulates a bulk order arriving from a supplier. Next, the fill container travel along the conveyor belt to the rack lane or the high bay warehouse. This acts as our centralized storage. The system automatically assigns a slot for every incoming container. When there is demand, the stock removal logic activates. The system retrieves a container from the rack and sends it to the output point. Once the container arrives at the buffer, manual handling begins. A worker is assigned to pick up at the item. The worker transports the container to the disassembly station. The function of this station is to separate the items. The empty container is sent to a specific buffer to be recycled. Meanwhile, the actual parts are sent to the store, ready for distribution. Now, looking at the 2D layout, we have multiply production lines. Label line A, line B, and so on. Each line has its own input buffer. To move part from the store to this line, we use an AGV. The AGV loops between the store and the line, delivering part based on demands. Finally, for the logic, the data tables serve as our database, listing all raw parts entering the system. The init method initializes the simulation and places the AGV on the track. And the load in unload method controls the AGV intelligence, telling it when to pick up and drop off material. These complete the circle from bulk storage to individual part distribution. Moving on the specific processing logic, we use a modular setup for the assembly line. For line A, we have very dedicated sources, data table, and buffer. We define the input in the data table. This data table lists the specific components required for the session, such as part A, part A1 through A4. The resources generate this part and sends them to the main buffer. From here, a sorting method distributes each part to its specific sub-buffer, ensuring the correct component goes to the correct lane. As the simulation runs, you can observe the part flowing from the sources, being sorted by the method and queuing up for the assembly process. At the assembly station, the logic is defined by the assembly table. This receipt specific that the station requires exactly one unit from each predecessor buffer to assemble the final product. Once assembled, the finished product exits the lines and moves to the drain. And here is how the simulation is running. Finally, to validate the system, we generate a summary report via the event controller. This allows us to verify throughput and ensure all production targets are met. That's all for our progress for this simulation. Thank you.